Okay, so good morning, everyone. Our topic for this week is all about central limit theorem. So what is this all about? So later on, you will know what is this central limit theorem. But before that, allow me first to present to you our learning objectives or learning competencies for this week. So what we are going to do now is to illustrate the central limit theorem. So ano nga ba ang ano nga ba itong central limit theorem, and how are we going to apply this central limit theorem in our statistics? Next, define the sampling distribution of the sample mean using the central limit theorem. Then, lastly, we're going to solve problems involving sampling distributions of the sample mean. So, let's start with central limit theorem. So, ano nga ba ang central limit theorem? What is the use of central limit theorem? Why is it that in statistics, there is central limit theorem? Okay, so in our previous lessons, we talked about normal distributions. Population that are normally distributed. So when we say normally distributed, meaning the graph is a bell curve, okay? So this is an example of a normal curve. So as you can see, ito siya, yung para siyang bell shape, kaya bell curve ang tawag doon. Now, there are cases or there are data in which this set or group of data is not normally distributed. Meaning to say, yung graph niya is hindi siya bell shape. So how are we going to address or how are we going to analyze this data if it is not normally distributed? So dito pumapasok yung gamit ni central limit theorem. Because as I have mentioned to you in our past lessons, we are talking about normal distribution, so we know the importance of normal distribution. Most of the data, most of the random variables that exist are somehow approximately normally distributed. But still, there are cases in which these data or variables are not normally distributed. So paano natin i-analyze? Paano natin i-study yung mga data, yung mga population, for instance, in which hindi siya normally distributed? So dito pumapasok sa central limit theorem. For example, ano nga ba itong sinasabi ni central limit theorem? So central limit theorem says that as the sample size increases, the distribution of the sample means, which yung ginawa natin last time, approaches a normal distribution. So ibig sabihin niyan, in case the population is not normally distributed, like for example, eto yung nakikita yung graph dito na tatlo. So we have here the parent population, uniform. So ganito yung shape ng graph niya, hindi siya normally distributed or hindi siya normal curve. Ito naman, we have exponential in nature. Then we have here parabolic in nature. So paano natin i-study yan? Hindi siya normally distributed. Can we use the standard normal distribution? Can we use the z-table? Can we use the z-score in interpreting this group of data? So, tama nga ba? Can we? Yun yung tanong natin ngayon. Now, ang sinasabi ni central limit theorem, pag yung population natin ay hindi normally distributed at kukuha tayo ng sample, okay? When you say sample, it's just a portion of the population, part of the population. So, kuha lang tayo ng sample from a population that is not normally distributed, that is not normal curve. So, ang sinasabi ni central limit theorem, pag kukuha tayo ng maraming samples doon sa population na hindi normally distributed, yung mga samples na yun, as the sample increases, yung sample will approach normal distribution. Nagiging normally distributed siya. So, yun yung sinasabi niyan. Okay, for example, dito sa graph natin, sa unang graph natin, uniform siya, di ba? Pag ganyan yung parang rectangle yung graph niya. Nakukuha tayo ng sample, let's say, 2 samples. So, anong nangyayari sa graph niya? Nagiging triangle siya. Parang nagiging triangle siya. Then later on, in-increase natin yung sample na kuha natin. Instead na 2, kuha tayo ng 5 samples, for example. So, up to, or let's say, sa baba, we have here 30 samples. Ano nangyayari sa curve? Nagiging bell shape. Nagiging normally distributed. Yun yung sinasabi ni central limit theorem. Another is yung exponential function natin or exponential distribution natin. So, ganito yung graph niya. Hindi siya bell curve. So, pag kuha tayo ng 2 samples, what happened? So, somehow nagiging bell curve na siya. Then, raramihan natin, dagdagan natin. Let's say we are going to take 5 samples, 30 samples, okay, until such time na nagiging bell curve or nagiging normally distributed. Ganon din sa parabolic. So, yun yung sinasabi ni central limit theorem. So, pag kukuha tayo ng sample from a population that is not normally distributed, that sample, as this sample increases, it will approach normal distribution. So, yun yung central limit theorem. We can still study samples, if not the population, kasi we cannot study the entire population, di ba? Because that is not normally distributed. But we can take samples out of this population that is not normally distributed, and we can interpret that as in normal distribution. Okay? As in normal distribution. But of course, there are cases in which we need to consider before applying this central limit theorem. Ano nga ba ito? Ano ba mga cases natin? Okay, what are the things that we need to consider before we apply central limit theorem? Okay, so central limit theorem, just like what I told you, the sampling distribution of the sample mean approaches a normal distribution as the size of the sample increases. Now, the question is, what if, let's say, yung population natin, 1 million, for example, then kukuha lang ako doon ng 5 samples. Will that 5 samples, can we use that already, or can we assume that 5 samples is normally distributed already? So, ano nga ba yung condition? Okay, the condition here is that the sample size must be at least 30. So, 30 above. So, ibig sabihin, kung 1 million yan, yung population mo, and that 1 million is not normally distributed, kukuha ka doon ng sample na at least 30. So, kung 30 above yung kinuha mong sample, for example, you can consider that already as a normally distributed group of data. Okay? But in case, halimbawa, yung population mo is not normally distributed. So 1 million yon, for example. Then kumuha ka lang halimbawa ng 20. That 20 na sample natin, we cannot assume that that is normally distributed. So we cannot use the central limit theorem. So I repeat, as ulit-ulit dito because this is very important, especially when we start solving problems already involving central limit theorem. So you can only use central limit theorem if the sample is 30 above. But if the sample is less than 30, and that less than 30 came from a population that is not normally distributed, then we cannot use the central limit theorem. Sir, paano naman kung halimbawa yung sample ko, sir, ay 10 lang, that is less than 30. Pero yung 10 na yun galing sa population na normally distributed. Can we apply central limit theorem? The answer is yes. Why? Because kahit less than 30 yung kinuha mong sample, yung sample na yun galing sa population na normally distributed, we can use the central limit theorem. But if that 10 sample came from a population that is not normally distributed, we cannot use central limit theorem. Is that clear?
Yes, sir.
Okay, so yun yung tatandaan ninyo. Okay? So, in-stress ko to ng paulit-ulit para at least ma-recall ninyo. So again, if the population is skewed, when we say skewed, whether it is more on the left or more on the right. So it's skewed to the left, to the right, or pwede rin jumbled, katulad ng present ko sa inyo dati na graph. No? The sample size should be at least 30, so that the sampling distribution of sample mean is approximately normal. So we can assume only a sample, na normally distributed if that sample is at least 30. If the population is normal, it follows that the sampling distribution of the sample mean is also normal regardless of the size. So gaya ng sabi ko, kahit less than 30 yan, kung yung less than 30 na yon ay galing sa population na normally distributed, we can still use the central limit theorem. Okay, so we are going to use the following formula. So the mean of the sampling distribution of means is equal to the mean of the population. Alam na natin yan in our previous topic. So kung ano yung population mean, yun din yung mean ng sample distribution natin or sampling distribution natin. In symbol, we have here. The variance of the sampling distribution of the sample means is equal to the variance of the population divided by the sample size n. So ito rin present ko dati sa inyo na formula. So variance yung may square, yung sigma, then may raised to doon yung may square. So the formula to get the variance of the sampling distribution, we have the population variance over n, small letter n. And what is this small letter n represents? This represents the sample size, kung ilan yung sample na kinuha mo from the population. Then for the standard deviation, guys, the standard deviation of the sampling distribution of the sample means is equal to the standard deviation of the population divided by the square root of the sample size. Meaning to say, ang na-observe ninyo dito, tingnan nyo, yung variance natin, in-square root lang natin. So, square root nito, yung population variance, we have here, wala na yung 2. Square root ni n, square root of n, of course. So, eto naman yung standard deviation. So, always remember na yung standard deviation ay square root ni variance. Kung yung variance natin, for example, ay 36, what is the standard deviation? If the variance is 36, what is the standard deviation?
6.
Okay, very good, 6. If the standard deviation is 10, what is the variance? If the standard deviation is 10, what is the variance? If the standard deviation is 10, what is the variance?
Square root of 10, sir.
Madi If the standard deviation is 10, what is the variance?
Ay, sir, 100.
Okay, very good, Santi. It's 100. I-square mo lang. No, given ka the variance, allow the standard deviation, i-square root mo. Okay, so yun. Then, an essential component of this central limit theorem, the average of your sample is equal to the population mean. So yun yung sinasabi natin kanina. The central limit theorem is important in statistics. Why? Because it allows us to at least assume that the sampling distribution of the mean will be normal in most cases. So central limit theorem is applicable for sufficiently large sample sizes. So ang recommended dito, again, paulit-ulit tayo, so n should be greater than or equal to 30. So in central limit theorem, when computing for the z value or z score, di ba? In our topic last time about areas under normal distribution, kino-convert natin si normal distribution into a standard normal distribution, yung may z value. So pag ganito naman, ang gagamitin natin na formula, pag involved na yung sample, eto, yung z is equal to, we have the sample mean minus the population mean all over the population standard deviation all over square root of n, which is the sample size. So ito yung gagamitin nating formula pag involved na yung sample. Okay, pag may sample na. Pero kung walang sample, we are going to use the original formula, yung ginamit natin na pag-convert ng z value noon. Okay, now para mas maintindihan natin at para malaman natin kung paano nga ba ginagamit or ina-apply itong central limit theorem, let's try to study some examples. Okay, for example, number 1. Will you read? Anyone would like? Kenneth, will you read? Kenneth.
The average number of milligrams of cholesterol in a cup of certain brand of ice cream is 660 milligrams, and the standard deviation is 35 milligrams. Assume that variable is normally distributed.
Okay. So the average number of milligrams of cholesterol in a cup of a certain brand of ice cream is 600 milligrams. So yun yung mean niya. And the standard deviation is 35 milligrams. Assume that the variable is normally distributed. First question, if a cup of ice cream is selected, what is the probability that the cholesterol content will be more than 670 milligrams? Okay? So what is the probability? So halimbawa, yung ice cream na yun, di ba? There's a certain brand of ice cream. It says there that yung mean niya or yung average milligrams of cholesterol is 660 milligrams. Now, ano yung possibility? Ano yung chance? Ano yung probability na when you try to get a cup of ice cream from that population, or let's say, yung mga produkto na yun, yung ice cream na yun, kukuha ka ng isa, what is the probability that you will get a cup of ice cream that is more than 670 milligrams? So yun yung question letter A, or first question. For the second question naman, it says here, if a sample of 10 cups of ice cream is selected, so paano kukuha ka ng 10 cups? So the first question, isang cup lang. Okay? But sa second question, paano kung kukuha tayo ng 10 cups? What is the probability that the mean of the sample will be larger than 670 milligrams? Okay. So ano yung difference ng dalawang questions na to? Sa first question, we don't consider sample. Instead, we are merely looking for the probability when we try to get 1 cup of ice cream. But in question letter B, there's a sample. Okay? And what's the sample size? 10 cups of ice cream. Now, pag kunin natin yung average number of milligrams of cholesterol, what is the probability that the mean of this will be larger than 670 milligrams? So, yun yung difference ng dalawang question. Yung una, walang sample. Yung pangalawa, may sample. Now, how are we going to address or how are we going to attack these questions? 2 questions. Now, let's consider the first one. If a cup of ice cream is selected, what is the probability that the cholesterol will be more than 670 milligrams? So probability na naman yung pinag-uusapan natin. So we will be using then the normal distribution. We will be using then the Z table. Okay, yung may area natin. Now let's try to illustrate the problem. The population or the population mean given is 660 milligrams. So dapat nasa gitna yon. Okay. Now the question in number 1 or letter A is that what is the probability that the cholesterol content will be more than 670? So where can we find 670? It is located at the left or right of the graph. What do you think? Saan natin makikita si 670? Is it located?
Right.
Okay, it's at the right of 660. So ito siya. Now, we are looking for the probability that is more than 670. Asan yun? Ito. So this portion of the graph or this shaded region represents the number or the probability that the cholesterol will be more than 670 milligrams. So nandyan. And in symbol, we have here P of X is greater than 670. And this is the normal distribution. Okay? Now, there's a need for us to convert this one para makuha natin yung area nito, i-convert natin into standard normal distribution para magamit natin sa Z table. Okay, so for 670, ang equivalent niyan ay 0. Now, there's a need for us to convert 660 yan. 670, there's a need for us to convert this one into a Z value or Z score. So, using this formula. Ito yung formula na ginamit natin last time. Kung nakikita ninyo, wala pa yung square root of n. Wala pa yung kaninang present kong formula. Why? Because hindi pa tayo kumukuha ng sample dito. It's just that we are looking for the probability when we try to get 1. Okay? Ito yung gagamitin natin na formula, yung dati. So in this case, to find the equivalent value of 670 in Z-score or Z-table or Z-value, we are going to use this one. So 670, substitute lang, minus 660 all over 35, which is the standard deviation. So we have here 0.29. So eto na. So yung 670, ang equivalent niyan in Z-value or Z-score is 0.29. And same lang yung shaded region natin. So in symbol, we have here P of Z is greater than 0.29. So na-convert na natin using this formula. Okay. So to find the area of this shaded region, of course, we will be using the Z table. Kaya nang ginagawa natin. Now, to find the area to the right of 0.29, since sa Z-table natin, ang nakukuha lang natin na value ay from 0 or between 0 up to the given Z-score. In this case, 0.29. So, ito lang yung nakita natin. So, we need to find the area of this. So, what is the area between 0 to 0.29? We have here 0.1141. So, ito yun. Nakita ninyo sa screen. Now, how are you going then to find the area at the right of 0.29? Anyone? Paano natin?
-0.50.
Yes, Kenneth.
Sir, i-minus po ng 0.50.
I-minus ng 0.50 or i-minus sa 0.50?
Minus sa 0.50, sir.
Okay, very good. So again, we know that half of this distribution or table or curve, I should say, is 50 or 50%. So 0.5, nandiyan na yan. minus the area between 0 and 0.29. So we have here 0.1141. And the difference is 0.3859. So meaning to say, pwede na natin tanggalin ito. And the area to the right of 0.29 is 0.3859. Very good. Now, of course, if this is 0.3859, so eto naman sa normal distribution natin is still 0.3859. So anong sagot dito? So the probability that the cholesterol content will be more than 670 is 38.59% or 0.3859. So yun yung sinasabi or yun yung sagot dito sa question number 1. Is that clear?
Yes, sir.
Okay, so ito i-recall lang. Recall lang ng topic natin. Now let's proceed to question number 2. Ngayon, the question now is, or the question involves sample. If a sample of 10 cups of ice cream is selected, what is the probability that the mean of the sample will be larger than 670 milligrams? I have a question. Since the sample is 10 cups, that is less than 30, right? Can we use the central limit theorem?
Yes, sir.
Yes, very good. Why yes, Sanchi?
Sir, sir, because it came from a normal distribution.
Very good. Exactly. Okay, so yung sample natin na 10 cups, that is less than 30. But that 10 cups of ice cream or sample natin came from a population that is normally distributed. So pwede natin gamitin pa rin si central limit theorem. Pero kung wala ito, tingnan nyo sa problem, nakalagay doon, no? Assume the variable is normally distributed. Kung wala yan, halimbawa, hindi niya sinabing yung variable natin or yung population natin ay hindi normally distributed, hindi naka-specify doon sa problem, 10 cups lang yon, hindi na natin pwedeng gamitin si central limit theorem. Kasi less than 30 yan. Okay, but in this case, kahit less than 30, pero galing naman sa normal population, we can still apply the central limit theorem. Okay, so let's just again illustrate. 670, that's the mean, ito. Now in our question, what's the probability that the mean of the sample will be larger than 670? So ito siya, it is located at the right side. Now again, we are looking for the area of this. Larger than 670. In symbol, meron na tayong X bar. X bar represents the sample mean that is greater than 670. And this is the normal distribution. Now there's again, there's a need again for us to convert this one into a standard normal distribution. Okay, 660, that is 0. Paano naman 670? What's the value? Tingnan ninyo, yung formula na gagamitin ko, eto na. Okay? So hindi na yung gaya doon sa first question natin. But we will be using this formula already. Why? Because sample na yung pinag-uusapan natin. Okay? So again, gamitin nyo lang tong formula na to pag may sample na involved. In this case, ang sample natin ay 10 cups. So in this case, we have here 670 minus 660 all over. Substitute lang tayo. And the standard deviation given is 35 milligrams all over square root of 10. What is 10? That is the sample size. Okay, sample of 10 cups, square root of 10. So substitute lang yung mga values natin. And the equivalent value of 670 in a z value or z score is 0.90. So again, it is located at the right of 0. Is that clear?
Yes,
Yes, sir.
Okay. Basta natin tandaanan nyo. Ano ko na dyan, if the sample, okay, we get a sample of blah, 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 sample of blah, 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 ay, dadya, the square root of n na to, sarad. Now, one timbaga ng sample, what is the probability that the blah, 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 ano ko na lang is siya, you use the original formula, yung first formula natin. Okay. In symbol, we have P of Z is greater than 0.90. So, ito yung area. So, standard normal distribution. Again, same process lang tayo. We look for the area at the right of 0.90 using our Z table. Okay, now, there's a need for us to find the area between 0 to 0.90. By looking at the Z table, what is the area between 0 to 0.90? Anyone? Kindly determine the area between 0 and 0.90. By
0.3159, sir.
okay, 0.31. Come again, Kenneth.
0.3159, sir.
Okay, 0.3159. Exactly. That's correct. So 0.9 ito siya. Okay, that is 0.3159. And of course, to solve for the area at the right of 0.90, ang gawin lang natin, 0.50 kasi 0.50 lahat ito, minus 0.3159. And what remains here is 0.1841. So, ibig sabihin, pwede na natin burahin ito. Yan. And the area of this is 0.1841. So, kung ito yung area nito, sa original graph natin or curve natin, yun din yung area natin, 0.1841. And what does this mean? Okay, so it says here that the probability that the mean of the sample will be larger than 670 milligrams is 18.41%. So ibig sabihin, pag kukuha tayo ng 10 cups of ice cream at kunin natin yung mean nito, the probability that the mean is greater than 670 milligrams is 18.41%. So yun yung sinasabi niyan. Okay, so that is one application of central limit theorem. So same process lang sila sa topic natin last time. Kaya lang ang pagkakaiba, ibang formula lang yung gagamitin. Kasi nga, involved na si sample. Sample number 2. Okay, will you read, Genesis?
A sample size of 32 is randomly selected from a population with a mean of 35 and a standard deviation of 10.5. What is the probability that the sample has a mean less than 36?
Okay, thank you. Let me repeat. A sample size of 32 is randomly selected from a population with a mean of 35 and a standard deviation of 10.5. What is the probability that the sample has a mean less than 36? Now, my question is the population normally distributed? Yes or no? Based on the problem. Is the population mentioned normally distributed? Yes or no?
No, sir.
No. So walang sinabi o walang naka-specify or walang statement doon sa problem natin na sinabi na assume that the population is normally distributed. Or hindi naman niya sinabi na the sample size of 32 is randomly selected from a normal population. Walang ganon. Wala yung term na normal. So hindi niya sinabi. Now, the sample size is 32. So yung 32 galing sa population that is not normally distributed. Question is, can we apply the central limit theorem? Can we assume that the sample size, which is 32, is normally distributed? Yes or no? Pwede ba nating sabihin na yung 32 na sample natin ay normally distributed?
Yes, sir.
How about the others?
No, sir.
Yes or no? O may nagsabing no, may nagsabing yes. Okay, what's the, why yes? Why is it that we can assume na yung 32 na galing sa hindi normal population ay normally distributed? Because what?
Kasi more than 30, sir.
Very good, Jenny C. Because ang sinasabi ng central limit theorem, pag kukuha tayo ng sample size na 30 above, kahit galing yun sa hindi normally distributed, we can assume na yung sample na yun ay normally distributed. So in this case, we can assume that that sample size of 32 is approximately normal based sa definition ni central limit theorem. Okay, so in this case, pwede natin gamitin si central limit theorem. Kung paano kung sinabi doon 12 lang, sample size of 12, can we assume that the sample size which is 12, a normal distribution? Pwede ba? Kung 12 lang? Can we assume? If the sample size is 12 only, for example. Sai, what do you think?
Sir,
No,
no.
sir. No, sir.
Okay, very good. It's no. So hindi pwede kasi less than 30 yan. Now in this case, greater than 30 or 30 above, we can assume. Okay, just illustrate first the given. The mean is 35. And ang question natin, what is the probability that the sample has a mean less than 36? So saan natin makikita is 36? Nasa right ni 35. Yan siya. And where is the portion of the graph that represents the mean that is less than 36? Tingnan natin. But before that, let's have to convert first yung 36 into z value. Okay, using this formula. So pwede natin gamitin ito. Kasi pwedeng i-apply sa central limit theorem. So ang given, sample mean is 36 minus 35, which is the population mean, all over the population standard deviation, which is 10.5, then all over square root of 32. 32 is the sample size. Then we have here a value or z value, which is 0.54. So ano ibig sabihin niyan? Si 36, ang equivalent niyan in z value is 0.54. In symbol, we have here P of z is less than 0.54. And where is the area that represents z that is less than 0.54? Of course, ito. Yan. So this area represents the sample mean that is less than 36. And in this case, pa sa normal or sa standard normal distribution natin, this area represents the, or this portion represents the area that is less than 0.54. Okay. So that is the normal distribution. Now, we can now use the z table. So what is the area? So there's a need for us to find the area between 0 to 0.54. So what is the area between 0 to 0.54? Anyone? What is the area between 0 and 0.54? May I call in Mangawang, Miss Mangawang?
Sir,
What is
0.1916.
0.1916. 1916. Are you sure? What is the area between 0 to 0.54? Is it 0.1916?
Sir, 0.0199.
0.0199. Tingnan natin. How about the others? Sige. How about the others?
Sir, 0.2054.
Okay, 0.2054. Tingnan ninyo paano nakuha. Okay, so 0.54 yon, di ba, Giselle? Now, tingnan natin sa baba or doon sa left side natin, tingnan mo natin si 0.5. Then, since 0.54 yan, hanapin natin si 0.04. Saan si 0.04? Ito siya. Okay, yan. Now, tingnan natin yung intersection nila. Okay? This one. So, yung intersection represents the area. So, in this case, we have here 0.2054. Is that clear, Giselle? Did you follow? Can you follow, Giselle? So, yan yung area.
Yes.
Okay, yes. So that's the area between 0 to 0.54. That is 0.2054. Now, how are you going then to find the area that is less than, or the area or the portion of the graph that is less than 0.54? Anyone? May I call in Miss Gutierrez? Paano natin hanapin ngayon tong area nito, yung shaded region? Or anyone from the group?
Add 0.5.
And 0.5 and
0.20.
2054.
okay, very good, Vladimir. Okay, and Kenneth. So in this case, para makuha natin yung area nito, we have 0.5 plus 0.2054. And of course, the total or the sum is 0.7054. So ito na yung area ng buong shaded region na to. And what does this mean? Okay, if this is 0.7054, of course, the original graph natin is still 0.7054. And it tells us that the probability that the sample mean has a mean less than 36 is 70.54%. So yun yung probability niya. So again, same lang yung process natin doon sa lesson natin noon. Kaya lang, ibang formula lang yung ginagamit natin. Kasi nga, sample na yung pinag-uusapan natin. Okay, another. Okay, Vladimir, will you read this question or example?
A sample size of 20 is randomly selected from a normal population with a mean of 40 and a variance of 25. What is the probability that the sample has a mean greater than 38.4?
Okay, thank you. So a sample size of 20 is randomly selected from a normal population with a mean of 40 and a variance of 25. What is the probability that the sample has a mean greater than 38.5? So 38.4. So the sample size is 20. Can we apply the central limit theorem to this problem?
No, sir.
No,
Yes
sir.
or no? Saan galing si 20? What?
Normal population, sir.
Okay. So galing siya, since 20 na sample size came or selected from a normal population. Can we apply the central limit theorem? Yes or no?
Yes.
Okay, it's yes. Even that is less than 30, but it came from a normal population, then we can still apply the central limit theorem. So let's just illustrate. Ang given sa question natin, what is the probability that a sample mean has a mean greater than 38.4? So i-convert natin sa 38.4, di ba? Now, substitute lang tayo. Sample mean is 38.4 minus the population mean, which is 40, all over. Ang given sa problem natin ay variance, which is 25. Paano kunin si standard deviation ulit pag ang given ay variance? Anong gagawin? Anong gagawin sa 25? Naramin tayo ni 25. Since variance yan. But in our formula, standard deviation yung kinukonsider natin. So paano natin kunin si standard deviation if the variance is 25?
Sir, get the square root of 25.
Square root.
Okay, very good. So, square root lang ni 25. Tatandaan nyo na dyan. Hanyo nga i-substitute nga sigod or hanyo nga i-substitute ni 25. Hindi formula tayo, but rather square root of 25 kasi variance yon. Kaya nakita nyo sa solution, we have here square root of 25. Okay? Hindi ko nilagyan ko ng square root. Then all over square root of 20. Of course, 20 is the sample size. So 20 lang yung kinuha natin ng sample. Then, of course, compute. Madali na lang yan. So negative 1.43. So let's try to illustrate. So the mean population mean is 40. 38.4. Saan natin makikita? Left ni 40. Okay, what is the area that is greater than 38.4? Okay, ito mamaya pakita ko. So we need to convert 38.4 into z value. In this case, ang nakuha natin is negative 1.43. Yan. In symbol, we have here P of z is greater than negative 1.43. So saan c greater than negative 1.43 or greater than 38.4 in our normal distribution? This one. So the area at the left or at the right, I should say, of 38.4. So that represents the mean that is greater than 38.4. In our standard normal curve or normal distribution, it's the area located at the right of negative 1.43. So na-convert na natin, we can now use the z-table. Yan. Okay, what is, since that is negative 1.43, we can use positive 1.43 as our reference. Now, there's a need for us to find the area between 0 to negative 1.43 on our z-table. Now, what is the area between negative 0 and It's the area between 0 and negative 1.43. Anyone? Look at the Z table.
0.4236.
0.4236.
Okay, very good. The two of you. Negative 1.43. So where can we find negative 1.4? Ito siya. Then yung 0.03. Yan. And the point of intersection is, of course, is 0.4236. So ito na ngayon yung area between 0 to negative 1.43. So again, ulitin, baka nalipatan nyo manan, ang area na nakukuha natin sa Z table ay from 0 to the given Z value. Always remember that. Now, what is then the area at the right of negative 1.43? Paano ulit natin kukunin yung shaded or area ng shaded region? We are going to what?
Add 0.5 to 0.4236.
Okay, very good, Christian. So we just simply add. Alam natin na itong malaking shaded region na yan ay 0.50. So 0.4236 plus 0.5 or 0.50, of course, it will give us a sum of 0.9236. Okay, so ito na yan. And of course, if this is 0.9236, 0.9236 wala tayo. And the probability that the sample has a mean greater than 38.4 is 92.36%. So yung probability niya. Okay, so that is the answer for this problem. Is that clear?
Yes, sir.
Yes.
Okay, let's proceed to our last problem. Oh, finally, makarelax kayo. The average public high school has 468 students. It should not be public high school. Dapat ko public school lang dito eh. Okay? Kasi yung sample natin, public elementary school. So the population should be public high school. So let me just correct the problem given. So the average public high school or the average public school has 468 students with a standard deviation of 87. So yeah. If a random sample of 38 public elementary schools is selected, what is the probability that the mean number of students enrolled is between 445 and 485? Okay, let me read again. The average public school has 468 students with a standard deviation of 87. If a random sample of 38 public elementary schools is selected, what is the probability that the mean number of students enrolled is between 445 and 485? Question. Based on the problem, is the population normally distributed? Yes or no? Sinabi ba doon sa problem na yung population ay normally distributed?
No, sir.
No. What is the sample size?
38.
38.
38.
Very good. 38 came from a population that is not normally distributed. Can we use central limit theorem? Yes or no?
Yes, sir.
Yes.
Yes.
sir.
So, dating gawi, ganun din. Form of formula man na. Kasi pwede na natin gamitin. Okay, let me just illustrate. The mean or the average is 468. And we are looking for the probability between 445 and 485. Ito siya. So again, 445, we can see that at the left of 468, while 485 is located at the right side of 468. And in symbol, we have here P of X bar, the sample mean greater than 445 but less than 485. So yun yung normal distribution yan. Now there's again a need for us to convert that into a standard normal distribution. So 0 yan, yung mean. Now i-convert natin using this formula. So substitute lang tayo. Una, i-convert natin muna si 445. So 445 minus the population mean, which is 468, all over the standard deviation given, which is 87. Then all over or divided by square root of 38. Why? Because a random sample of 38 public elementary schools. then we get negative 1.63. While for 485, substitute naman si 485 minus the population mean for 468, then all over the standard deviation, which is 87, divided by square root of 38, which is the sample size. And we get 1.20. So madali na lang yan. Substitution lang. So 445 ulitak, that is negative 1.63. 485, i-convert natin, that is 1.20. Okay, since we in symbol, we are looking for the area between z is greater than negative 1.63 but less than 1.20. And where is that area? Eto. Area na to. Okay, so yun yung hanapin natin. And meron na tayong ganito, we can now use the z table. Okay? So to find the area between negative 1.63 and 1.20, there's a need for us to find the area between 0 to negative 1.63 and the area between 0 to 1.20. Unahin natin si area between 0 to negative 1.63. Anyone would like to give the area?
0.4484.
Okay, very good. So 1.63, we can use positive 1.63. Ito yung 3 niya. So 0.4484 or 4484. So ito yung area nito. Okay, so that's very clear. How about the area between 0 to 1.20?
0.3849.
0.3849.
Okay, very good. So 1.20, 0.3849. Yan. And how are you going to find the area between negative 1.63 and 1.20? We are going to
Add 484 and 849 minus 100. Then
okay,
minus
very
100.
Okay, very good. Prince and the rest. Just simply add. So 0.4484 plus 0.3849, ang total niyan ay 0.8333. So pag-addin mo lang itong dalawang to. Okay? So ibig sabihin, ito yung area between negative 1.63 and 1.20, that is 0.8333. In our normal distribution, so the area between 445 and 485 is also 0.8333. And of course, the probability that the mean number of students enrolled is between 445 and 485 is 83.33%. So yan yung probability. Yan yung chance na pagkukuha ka ng 38 public elementary schools, ang probability niya na ang mean nila or number of students is between 445 and 485 is 83.33%. Is that clear?
Yes, sir.
Okay. Do you have questions?
None.
Things that you need to
None,
add
sir.
in our discussion? Wala na? Okay, so if there are no questions, but still, kung mayroon pa kayong questions as you go over this one, feel free to raise that in our GC for everyone's consumption. Ibagay lang dyan, sir, what is the meaning of this, or what does this mean, and so on and so forth. Ibagay dyan because possible that your question is also the question of your classmates. Kaya lang nahiya silang magtanong. So thank you for listening. Do not leave yet. Allow me first to capture our attendance. Okay, thank you for listening. God bless us all. Later on, I'll be sending to you a copy of this presentation. At the same time, the activity that you need to accomplish for this week. Para naman mabasa, ma-analyze din ng mga iba, especially those who did not attend our online class today. So again, be reminded to attend your online classes, not only in my subject regularly. Okay, because your attendance is strictly monitored. So thank you and God bless us all. Do not leave yet. Agpala ang mga laang ti attendance tayo. Okay, so thank you and God bless us all. Enjoy the rest of your day.
Bye, sir.
Bye,
Thank
sir.
you
Thank you
po.
po.